In my last video, I talked about Carpinteria's vulnerability to sea level rise. I showed how if 1 foot of sea level rise happens, it would cause some worry for the beach neighborhood. 2 feet would be a problem, and 3 feet would be a severe problem. In this video, I'll talk about what experts say about how much sea level rise Carpinteria can expect and when to expect it. As I said in my last video, I'm not a scientist, and these are my own views as a private citizen. The last video was all shot down near sea level. For this one, I thought I'd head up the Franklin Trail, try and give some perspective. Plus, there's something cool up there I want to show you. Cars, computers, smartphones, modern medicine. A lot of the things we take for granted in society were the result of the slow, incremental progress of science. We non-scientists are usually pretty good at benefiting from scientific knowledge. Once in a while something gets in the way of that, some cultural value or group affiliation that makes it hard for us to accept what science says. But that's rare, and usually involves things that aren't very important in our day-to-day lives. According to scientists, climate change is real. It's happening due to human activity, and sea level rise is one of the things it's going to cause that we'll have to deal with. They say that sea level rise will happen due to a number of factors. Some of the big ones are thermal expansion, where the ocean heats up and it takes up more space, and melting of land ice and glaciers, especially in Greenland and Antarctica. So, you may think differently, which is fine, but I hope if you think differently that you'll still watch this video and let me know what you think about it. I'm going to look at 4 different predictions. Each comes from a government body summarizing the science about sea level rise for the benefit of decision makers. This first prediction is from the Intergovernmental Panel on Climate Change, or IPCC. This is from their 5th assessment report, which came out in 2013. The amount of sea level rise is given in meters, so I'll add a red line representing the 2-foot level where Carpinteria's beach neighborhood would start to have serious flood problems. There are 2 colored wedges, a blue one and an orange one. The blue wedge shows an optimistic scenario. That's the prediction for a future in which humanity quickly eliminates greenhouse gas emissions. The orange one shows a more pessimistic scenario, one in which we keep burning fossil fuels and emitting greenhouse gases pretty much the way we do now. Each wedge shows a range of uncertainty on either side of the central prediction. In the optimistic scenario, we wouldn't hit 2 feet of sea level rise until after 2100. In the pessimistic scenario, we'd likely hit 2 feet sometime in the later part of this century. I'm not trying to get you to limit your own greenhouse gas emissions. Such mitigation efforts are important, but that's not what I'm talking about in these videos. Now, mitigation will succeed or fail based on the sum total of human activity across the whole globe. Adaptation is the other side of that. It says whatever amount of climate change we're not able to avert with our mitigation efforts, what can we do to adapt to it locally? I'm not very hopeful about humanity's ability to come together quickly to reduce greenhouse gas emissions, but I am more hopeful about Carpinterians' ability to come together to prepare for the sorts of problems climate change is going to cause. Here's the second sea level rise prediction I'm going to show you. This is from the US government's National Climate Assessment that came out in 2014. Again, optimistic scenarios are toward the lower end of the prediction, and pessimistic scenarios are toward the top. The dark gray wedge represents likely sea level rise, which is the same thing the IPCC graph we were just looking at showed. If you look closely though, this graph also has a lighter shaded area above and below the dark gray area. That represents unlikely but possible amounts of sea level rise. If you follow the 2-foot line across, you can see roughly when Carpinteria's beach neighborhood would get into trouble under different scenarios. Around 2050 for the worst case scenario, the 2060s for the most pessimistic likely scenario, and around 2100 for an intermediate scenario. More optimistic scenarios wouldn't reach the 2-foot line until after 2100. We've looked at predictions from international and national authorities. Here's one from the state level. This Coastal Commission graphic shows a number of different sea level rise predictions. Instead of showing curved graphs of sea level rise over time, in this chart the bar for each study represents the amount of sea level rise predicted by that study for the year 2100. The predictions are in meters. Here's a line to show the 2-foot level. As with the previous graphs we've looked at, pessimistic scenarios are toward the top of each bar, and optimistic scenarios are toward the bottom. The red bars are for studies that looked at global average sea level rise. Blue bars are for studies that made predictions just for California. After reviewing these studies' predictions, the Coastal Commission recommended using this one I've circled. It's from a 2012 National Research Council study. The blue bar just to the left of it is for the same study's prediction of sea level rise north of Cape Mendocino. The reason there's such a difference between the two predictions is vertical land movement. North of Cape Mendocino, the shoreline tends to be moving upward. Here to the south, it tends to be moving downward. Not very fast, but enough to make a difference for a slow process like sea level rise. We don't usually notice land movement because we live our lives too quickly to see it, but it's there if you know what to look for. One example is that prominent cliff behind Carpinteria, where the kids from Carp High like to paint their graduation year. Originally, that slab of rock was horizontal, because that's how it formed, as a layer of sandstone at the bottom of a shallow coastal sea. But since then, it's been tilted up to the 60-degree angle you see today. Here's the last study we're going to look at. This one just came out in February 2017. It's from the U.S. National Oceanographic and Atmospheric Administration, or NOAA. Like the U.S. National Climate Assessment graph we looked at earlier, this one includes extreme low and extreme high projections for scenarios that are possible but unlikely. Here it is with the 2-foot line added. As you can see, it's not a very comforting picture for Carpinteria. This incremental progress takes some work, but it adds up. And as the science on climate change and sea level rise has made incremental progress, it's come into focus. When I first started paying attention to this issue, the projections for future sea level rise tended to be lower because there was a lot of uncertainty around this issue of Antarctic land ice and how quickly it would melt. Would it melt in a few centuries or in a few millennia or in a few hundred millennia? From a geologist's perspective, those are all roughly the same, but from a climate change projection perspective, they make a big difference. The more recent projections, as that science has firmed up, have tended to get scarier. Scientists, most of them, these days are saying they think the Antarctic ice could well be melting more quickly rather than more slowly. And that makes a big difference. One thing that might help Carpinteria avoid some of the effects of sea level rise is very local land movement. I talked earlier about how the coastline north of Cape Mendocino is moving slowly upward, which helps offset sea level rise there. Maybe there's some land movement around here, movement that's too localized to show up in the statewide studies, that could likewise help us. As it turns out, no, there probably isn't. The geology around Carpinteria is pretty well understood. If anything, the land under Carpinteria's beach neighborhood is slowly sinking rather than rising, so that won't help us with sea level rise. It's human nature to think things will always stay pretty much the same as they've been during our own lifetimes, but people who study the Earth's climate know better. The climate has been pretty stable since the end of the last ice age, about 10,000 years ago, but that's likely to change thanks to the greenhouse gas experiment we're running. Looking back through the Earth's history, you can see evidence of previous big changes. The timescale in each section of this chart is compressed by roughly an order of magnitude, so as we scroll left, we're covering more and more time. It's hard for me to comprehend a span of time this long, but at a point almost 40 million years ago, during the late Eocene, the Earth was going through a dramatic cooling. For a long time it had been warmer than it is today, with no permanent ice at the poles. But then, as things got colder, ice caps started to form, and the seas fell. And you can see it. You can see the evidence of those seas falling. This is the thing I wanted to show you. So right here, this over here, this rock next to the path here, that's that cold water formation sandstone that the kids like to tag with their graduation year. But here, the top of it isn't exposed the way it is at that cliff. Instead, the overlying layer is present. And you can see the transition. So here on this side, this is sand building up into sandstone, laying down on the floor of a shallow coastal sea. But then all of a sudden, it turns into this reddish conglomerate with pebbles mixed in, and that's land deposition. All of a sudden, this spot is dry land, and instead of sandstone, you have alluvial flows. You have like floodwaters that are spilling out of stream beds and bringing in mud and pebbles that have been worn smooth in their stream beds, and you can see it right there. I mean, you can touch it. It's real, and geologists, people who study the Earth's past, they know how to read that, and they can reconstruct that history. And just like they can reconstruct that history, they can see what happens when carbon dioxide levels go up. They can see what happens when we do that today. I was born in 1962. According to the actuarial tables, my average lifespan as a U.S. male is 78 years, which would get me to 2040 or thereabouts. So it would take a combination of good luck for me and bad luck for everybody else for me to live long enough to see 2 feet of sea level rise in Carpinteria personally. So it's not likely to be a problem that I experience the effects of firsthand, but I think it's an important problem for people of my generation to think about and plan for, so that our children and grandchildren who do experience it have better options to choose from. So what are the approaches we could take preparing for sea level rise in Carpinteria? What can we do about it? I'll talk about that in my next video.